The final question on the paper, question 21, is a question about tessellation. Okay, so it's how shapes fit together. It says Maggie has lots of tiles. All her tiles are in this shape of regular polygons. So a polygon is a straight-sided shape, and a regular polygon is one which has all the sides the same length. So for example, an equilateral triangle would be a polygon, or a square would be a polygon, because their sides are all the same length and all the sides are straight. It says the edges of all tiles have the same length. There we are. She places two 12-sided tiles to meet edge to edge. Maggie places a different shaped tile with two of these tiles. She finds that the three tiles tessellate. Okay, what that means is those three tiles will fit together with no gaps. By calculation, find the number of sides of this third tile. You must show all your working. Okay, so if we imagine what the tessellation might look like, we'd have this 12-sided tile joining this 12-sided tile, and if we think about it, it's going to, have 12 sides. It's going to be, because there's so many sides, it's going to be quite circular in shape. So they're both going to come away like this from each other where they join. Okay, and it says that Maggie places a third tile edge to edge. So there's another tile in here, and we need to find out how many sides are on this tile. So what we can do is use our knowledge of angles to help us with this, because all of those angles there will have to add up to 360 degrees for it to be a tessellation, because we can't have any gaps. Okay, so if we know the interior angle of a 12-sided polygon, the 12-sided tile, then that will help us. Okay, so to work out the interior angle, there's two ways we could do it. Okay, I'm going to work out the exterior angle first by doing 360 degrees divided by 12. So I know that the exterior angle is 30 degrees. So the interior angle will be 180 degrees, subtract the exterior angle of 30. So the interior angle will be 150 degrees. So we know that that angle is 150 degrees. And we know that that angle is 150 degrees because they're both the same, because they're 12-sided shapes. And they've got to all add up to 360. So 150 degrees plus 150 degrees plus the interior angle of the third tile must total 360. So that's 300 degrees plus what we're working out equals 360 degrees. So that interior angle, missing one, must be 60 degrees. And if we think about it, if we've got polygon, a regular polygon, so all those angles would be the same. When we think about regular polygons, we know that a regular polygon with an interior angle of 60 is actually an equilateral triangle. So the third tile has 3 sides. Here's a further question on tessellation. If you have a go and then press pause, then you can see how you've done. Okay, so it says Ben needs to tile his kitchen floor and decides to use the 2 types of tiles shown in the diagram. By drawing more tiles in the diagram, show that all the tiles will tessellate. So I'm going to carry on down here. Some more of these shapes. Here we are. In the exam, might be a good idea to use a ruler if you have time. Make it a little bit neater. Here we are, and I think I might go back up doing some more of these ones. And of course with the tessellation you won't have any gaps. There we are, coming down, and you can see that how the pattern continues. If you carry on and fill up the space, then make sure that you get all of the marks. Oops. There we go, mine's a bit of a sketch, but you can see they clearly tessellate with no gaps between the tiles.